What is the deadliest threat to the human species? Nuclear war? Global warming? No. The ultimate weapon of mass destruction is a lump of rock spinning through space. It appears almost peaceful, serenely floating through the infinite vastness of the cosmos. Yet this 200 million tons of rock contains more energy than the explosive power of every nuclear bomb on Earth. Naked science now gives you a ringside seat to a massive extraterrestrial impact that, if it happens, could trigger human extinction. Traveling at 50 times the speed of sound, this rock smashes through the protective layer of the Earth's atmosphere as if it weren't there. It strikes, releasing an explosive force equivalent to 100 million megatons of TNT. Across the globe, mega tsunamis and earthquakes flatten cities. Within hours, a plume of vaporized rock bursts through the upper atmosphere, expanding around the entire planet. It re-enters as trillions of meteorites, heating up the air to the temperature of an oven. Dust settling in the atmosphere blots out the sun, plunging the planet into total darkness. More than 1.5 billion people die by the end of the day. It could be the beginning of the end for humankind. Hope we have your attention. You may think the Earth inhabits a quiet little corner of the solar system. No. In reality, we live in an extremely dangerous neighborhood. Instead of calmly floating through space, our planet is traveling nearly 70,000 miles per hour through the middle of a celestial shooting range. Speeding through space with us are millions upon millions of lumps of rock. They range from a few feet across to boulders the size of Texas. As we hurtle through space, these rocks cross our path continually. And lacking a giant steering wheel, the Earth has no way of avoiding them. Another threat lurks out there. Comets, frozen lumps of ice and dust, sweeping in from the furthest reaches of the solar system at almost unimaginable speeds. So what are the odds? The chances of an asteroid killing millions of us by the end of the century are 1 in 20,000. We are 4 times more likely to be struck by an asteroid than hit by lightning. The moon, pockmarked from constant bombardment, shows the destructive powers contained within these deadly rocks. Yet the Earth has been hit as often as the moon. When it comes to celestial bombardment, the human race has been lucky so far.
One could strike right this minute, right this second, and totally change life on Earth and possibly extinguish our species.
A rock such as this, when it hits, would have devastating explosive power.
50 million tons of rock coming at 60,000 miles an hour, 10 times all of the nuclear weapons on Earth at the height of the Cold War, going off in one spot.
Yet how can a mere rock wipe out something the size of our planet? And what are we doing to avert such a disaster? The answers may lie in some radical experiments. We examine the threats from comets and asteroids and investigate how scientists are battling to ensure that we can save life on Earth. But first, the evidence. We can find proof of previous bombardments from space here in northern Arizona. This is Meteor Crater, nearly a mile across, 550 feet deep, big enough for 20 football games simultaneously, along with 2 million fans. Scientists originally believed that volcanic activity formed this crater. Then, geologists discovered startling evidence that about 50,000 years ago, a rock from outer space blasted this giant hole. Back then, Neanderthals walked the planet. And this Arizona desert was a temperate wooded plain. And then, out of the sky, a rock about 150 feet across smashed into the ground. It struck with an explosive force greater than 20 million tons of TNT. So how could a rock leave such a massive scar on the landscape? As it entered the atmosphere at over 50,000 miles per hour, friction heated up the asteroid and the air below it to 100,000 degrees Fahrenheit, 10 times hotter than the surface of the sun. But the killer punch was the kinetic energy, the energy of motion stored in the rock. When it hit, that energy became an explosive blend of heat, light, and sound. The asteroid vaporized on impact, launching a cubic mile of rock into the sky. The debris rained back down to Earth, crushing everything within a 5-mile radius. It flattened or killed everything within 50 miles. And this was just a small asteroid. For the full story of the crater, we turn to Eric Asfog, a scientist who specializes in impact crater research. Asfog has been studying asteroids for over a decade. He even has one named after him, 7939 Asfog. Scientists have always cared about asteroids, but as recently as 50 years ago, most thought that they were just harmless lumps of rock zipping around in space. But here at Meteor Crater, scientists uncovered the first clues showing how destructive these harmless rocks could be.
It's one of the most significant holes in the ground on Earth. As recently as the 1950s, it certainly wasn't accepted that this was an impact crater. It was a revolutionary concept in modern geology.
These rocks had been struck by an explosive force far more powerful than any volcano. It changed their very structure.
The smoking gun for a meteorite impact hypothesis was a unique phase of mineral, quartz mineral.
Hit a rock with a hammer and it breaks. Hit it with a truly massive force, and this is what happens. The quartz fractures. Here on Earth, only one process can make what's called shocked quartz. A nuclear explosion. Only something this destructive creates the immense pressures needed to alter quartz in this way. Or an even more powerful force. A big rock from outer space. These discoveries at Meteor Crater led astronomers to begin to take a closer look at asteroids. Scientists found so many asteroids, they started to connect the dots. Space rocks must have hit the Earth many times. The pockmarked surface of the Moon, littered with craters, offered strong supporting evidence. Asfog and others believe an asteroid the size of Meteor Crater hits the Earth every 1,500 years. In fact, an asteroid or comet the size of the Meteor Crater rock may have hit as recently as 100 years ago. In 1908, a vast explosion flattened thousands of square miles of Siberian forest. Luckily, this was truly the middle of nowhere. No one died, But had that strike hit a city, it would have killed hundreds of thousands. So it's clear that the Earth has been getting bombarded from space. But why doesn't our planet's surface look as cratered as the Moon? To answer that, we traveled to Manson, Iowa, the site of one of the biggest impacts ever known. Can we protect our planet from the threat of a killer rock from space? We've seen how often the planet has been bombarded and how it took a big hit in Siberia as recently as 1908. Yet the scars aren't easy to find. Could there be impact craters that nature has simply hidden? This is Manson, Iowa. It looks like many other small towns in America. But Manson has a secret. For years, geologists knew that something was odd about the land around here. Abnormalities had been uncovered as far back as 1912. But just as at Meteor Crater, the scientific community believed that ancient volcanic activity was the culprit. Then, in the mid-1980s, two geologists began a series of drillings. What Ray Anderson and Brian Witzke found changed everything.
As the core came out of the ground, right away we knew there was something that was totally unusual about it. You get a big mixture and juxtaposition of rocks that are normally thousands of feet apart. You'll find a fragment of rock from 10,000 feet down mixed with one that was right at the surface. So something happened to mix all of these up. Once we got a chance to look at them under a microscope, there was nothing in all our years of geologic training to prepare us for what we saw.
The most definitive evidence for large-scale impact at Manson is what's called shock quartz grains. Such tremendous shock forces move through the ground related to this giant explosion. These require such high pressures, there's no way that they could happen under any kind of crustal process that we're aware of.
They'd found shocked quartz on a site 75 million years old. That could only mean one thing: an asteroid impact. So what happened here 75 million years ago?
That day when the meteorite hit at Manson was certainly a very bad day for anything that was in the vicinity. This meteorite would have been somewhere in the area of about 1.5 miles in diameter. That would be something on the order of 50 million tons of rock coming at 60,000 miles an hour. That big a rock at that speed would have not noticed the atmosphere, would have hit the Earth, it would have penetrated into the Earth about its own diameter. And that amount of energy was truly tremendous. 10 times all of the nuclear weapons on Earth at the height of the Cold War going off in one spot.
The asteroid completely vaporized, along with millions of tons of rock and earth.
That vapor would have been shot straight up into the stratosphere and distributed worldwide, blanketing the Earth, basically.
The crater the asteroid carved would dwarf the Grand Canyon. And yet today, there's no visible trace of it. How could such a gigantic hole in the ground have vanished into thin air?
The reason that there's nothing to see there today is because Iowa's been glaciated many times, and the last time the glaciers came into Iowa, 12 or 14,000 years ago, they blanketed the Manson impact structure beneath 50 to 150 feet of glacial deposits.
There was a tremendous amount of devastation, and yet the Earth has managed to cover it all up, and you wouldn't know it's there.
Scientists believe the Earth has been bombarded by asteroids as many times as the Moon. The difference is, the Earth has an astonishing ability to heal its own scars. Unlike the Moon, a barren rock with no atmosphere, the Earth is alive, and its wind, rain, and ice cause constant erosion. Today, there are only a few hundred visible craters left, recording the impacts of these asteroids. But exactly where have these extraterrestrial bombs come from? There are more than 1 billion orbiting in loose formation between Mars and Jupiter, from tiny pebbles to some that are hundreds of miles across. They're spinning through space, moving 30 times faster than a fighter jet. They're the remnants of some would-be planet that at the dawn of the solar system never quite made it. Instead, the awesome gravitational pull of the giant planet Jupiter kept the rocks apart. But sometimes these rocks crash into each other and set off on different orbits closer into the Earth. These are called near-Earth asteroids. They're the real threat to us as they cross the Earth's path around the Sun. They make our part of the solar system a more dangerous place to live. How dangerous? The proof occurred 65 million years ago, when the Earth collided with possibly the largest asteroid ever. A lump of rock so massive that the moment it hit the ground, the back end of it was still more than 6 miles up in the air, higher than the world's tallest mountain. This asteroid impact was so powerful, it may have changed the course of life on Earth. Repeated asteroid impacts on the surface of the Earth have left hidden clues to a moment when life here nearly ended, and to an explosion so awesome that it wiped out 75% of all life on the planet. Some of those clues lie in Trinidad, Colorado, with scientist Dan Durda. Durda is one of the key figures in asteroid research. He's been studying these killer rocks for 20 years. He too has an asteroid named in his honor. These rocks harbor convincing evidence of the ultimate dinosaur massacre, with nature as the hitman. In the lower rocks, dinosaur fossils exist in abundance, but above a clear boundary that the scientists call the KT boundary line, the dinosaurs disappear. So what happened to the dinosaurs? The answer lies here, hidden within this thin white layer of rock. This band of rock contains iridium, a metal so rare on Earth that the average rock contains just 1/billionth of a part of it. Yet in this layer, iridium levels are 200 times normal. Where else do you find a lot of iridium? In space, where it's 1,000 times more abundant than on Earth. The white layer also reveals evidence of shocked quartz, just as at Manson and Meteor Crater. Only an asteroid could leave such a mark. Extra iridium and shocked quartz appear within KT layers at many points around the planet. Such a global footprint could only have come from a truly awesome impact. The asteroid struck near what is now the Yucatan Peninsula in Mexico.
The impact that occurred 65 million years ago was truly enormous. It dwarfs anything in scale that we've ever witnessed in human civilization. The asteroid or comet that struck the Earth at that time was about 6 miles across. It plowed into the surface of the Earth at over 40 times the speed of sound. It was so enormous that when it struck the Earth, its leading face, when it contacted the surface of the Earth, its trailing face was still up at 35,000 feet. That's the altitude that jetliners fly. So this was an enormous mountain of rock slamming into the surface of the Earth.
The energy of the impact was more than 6 million times that of the 1980 eruption of Mount St. Helens. The initial blast knocked down everything within several hundred miles. It flattened whole forests. The shock of the impact created massive earthquakes around the globe. Worse was to come. The plume of vaporized rock broke through the upper atmosphere. Some of the material was blasted halfway to the moon before falling back to Earth.
All of this material re-entering the atmosphere behaved like so many trillions of meteors. That material heats the atmosphere, in fact warming the upper atmosphere to temperatures the equivalent of the inside of a household oven turned to broil.
Some contend that in the following months, dust blocked out the sun. Darkness enveloped the planet. Deprived of sunlight, most plant life died. Animals that eat plants starved. The food chain snapped. The impact released a torrent of carbon gas, the equivalent of 3,000 years of modern fossil fuel burning. It was global warming on a fast track.
It's every environmental catastrophe that you can possibly think of all happening together at the same time.
But we mammals should be grateful for this particular catastrophe. The dinosaurs had ruled the Earth for 150 million years. Their extinction allowed mammals to evolve and dominate the planet.
If it weren't for that impact 65 million years ago, we wouldn't be here. It truly was the crucible of human evolution.
But there's a possible twist. Just as an asteroid ended the reign of the dinosaurs, such an impact today could wipe out the human race.
A KT-size impactor hitting today in Los Angeles, say, would immediately lay waste and blast flat everything from Denver up to Seattle. In fact, the whole North American continent would be wiped out, and I truly doubt that humans anywhere on the planet would survive such an impact.
But just how real is the danger that we may one day go the way of the dinosaurs? One dedicated asteroid hunter understands the risks better than most. David Levy.
The Earth is traveling on a superhighway, and this particular highway that the Earth has no entrance ramps and no exit ramps, but it does have cross streets. And every one of these cross streets is in orbit of an incoming asteroid or comet. Right now, one of them is crossing our interstate, but we're not there. What we have to worry about is, does one of these objects cross our highway when we get to it?
Every night, Levy works out of his converted garage, scanning the skies for what he calls celestial terrorists.
We take a picture with a CCD, then we take a second one, then we take a third one, and then the computer automatically scans it. And as you can see over here, it has found an asteroid. It looks like a star, but it moves across the background of fixed stars. And the telescope and the clear sky have caught that asteroid.
Thanks to Levy, the world was able to see for the first time the awesome power of a celestial body smashing into a planet. In 1993, David Levy co-discovered a comet on a collision course with Jupiter.
We had no idea what to expect. Shoemaker-Levy 9 might only be about a mile across. Jupiter is so large that if you poured 1,000 Earths into it, you'd still have room for 300 more. Nothing's going to happen. We're not going to see anything. Boy, were we ever wrong. The comets collided with Jupiter at a speed so fast that had they been crossing the United States, they would have crossed it in 1 minute. 140,000 miles an hour.
The comet slammed in pieces into the planet, creating a tunnel of fire. A huge plume of gas rose up through the tunnel. Massive quantities of dark material dropped onto the top of Jupiter's atmosphere. The collisions left a string of scars that were still visible a year later. Each scar the size of Earth.
It was a chance for us to see nature's awesome power It was as if nature was really teaching us something. Here is how I work. Here is how planets form. Here is how life forms from these planets. Everybody just look at Jupiter and get a lesson in your heritage.
Levy and other scientists believe that comets and asteroids are not just forces of destruction. The Earth was bombarded by comets and asteroids 3.8 billion years ago. One theory is that these rocks contained water and carbon-based molecules in sufficient quantities to trigger the beginnings of life.
It's kind of interesting to think of them as the possible source, a possible ancestry in the night sky, and a very dangerous ancestry. The birth of life has got to be a very violent thing if it comes from the collision of a comet with the Earth. And we saw in 1994 the tail end of that early solar system violence, the collision of a comet against a planet. It's still happening. It happened back then every day, but now it's happening on Jupiter every couple of centuries, and we were lucky enough to see it.
When humankind witnessed the collision of Comet Shoemaker-Levy 9, the shock kick-started a program of asteroid and comet searches funded by NASA. The race was now on to find these potential planet smashers. Many scientists believe it's only a matter of time until an asteroid hits the Earth. So what are our leaders doing about it? Right now, the answer is very little. And alarmingly, we've recently had a very close call. A lump of rock that passed so close to the Earth, it was the cosmic equivalent of a bullet grazing our skin. March 2004, an asteroid 100 feet across hurtles through space at 50,000 miles per hour. It's just 48 hours away and heading in our direction. Researchers have spotted it from their high-tech astronomical observatory in the desert of New Mexico, home to America's leading band of asteroid hunters. While most people remain blissfully unaware, scientists calculate the orbit of the newly designated asteroid, 2004 FH. It's circling the Sun every 9 months between Venus and Earth. It's going to be close, closer than any other asteroid ever discovered nearing our planet. 2 days later, 2004 FH skims over our heads, 26,000 miles above the Earth, near where weather satellites orbit the planet. Captured here on film, it flashes over the southern Atlantic Ocean, close enough to be seen through binoculars. 2004 FH would probably have broken up on entry. But if a larger asteroid ever hits, we're in big trouble. This time we were lucky, but there are millions of rocks out there, and one of them could have our name on it. We've already demonstrated the cataclysmic effects of a 6-mile-wide asteroid smashing into the Earth, wiping out the dinosaurs. And if a big rock is out there right now heading in our direction, just who is trying to find it? Amazingly, the only government doing anything of significance right now is the United States. The annual budget for this asteroid hunt is just $4 million. It's been said there are more people working in an average fast food restaurant than there are scientists tracking asteroids. Most scientists who are tracking asteroids work here in the deserts of New Mexico. This is the Linear Survey, the largest asteroid tracking program on the planet. The Linear team discovered our near-miss asteroid 2004 FH, the 100-foot slab of rock that brushed past the Earth. Jennifer Evans of Linear tells the story of that near-miss.
2004 FH came to within 26,000 miles of the Earth. To put that in perspective, that's where the telecommunication satellites are, the TV satellites, the weather satellites that we're all familiar with.
Scientists believe 1,000 asteroids over half a mile across are now in near-Earth orbit. NASA has set a target for Linear and other survey groups of finding 90% of them by 2008. To date, they've found 60%. So far, none of the asteroids located are due to hit us. But alarmingly, we know nothing about the remaining 40% that we haven't located.
This is a plot of the inner solar system, and if you look around at the circles, outside is Jupiter, Mars, Earth, Venus, Mercury, on into the Sun. What you can see here in green is actually the main belt asteroids. There's over 200,000 of them known. In red are all of the near-Earth asteroids. Those are objects that are crossing the path of Earth at some point or another. Gives you a feel for the density, the type of environment that the Earth is cruising through every single day.
In the race to locate all the near-Earth asteroids before one strikes, the Linear program runs 360 days a year. Using 2 telescopes, they record a series of digital images. The computer then removes any objects like stars that do not move. Anything moving is likely to be an asteroid. In the course of one night's viewing, they record 7,000 frames of digital pictures. They can find as many as 100 new asteroids on a given night. The computer program is so sophisticated, it located 3 asteroids obscured by the brightness of this star. But even when the Linear team finds an asteroid, they don't instantly know if it poses a threat or not.
When we spot an asteroid, it's a 2-dimensional image, and so there are an infinite number of locations where that asteroid can be. It could be very close to us, or it could be out beyond the main belt.
The team can only get an accurate position on the rock by observing it from different points over several days. When they can plot the orbit, they can see if it is on a collision course with the Earth. Simply counting all the near-Earth asteroids is not going to prevent an asteroid strike. We have to find ways of dealing with the threat. But before we can work out how to defend ourselves, we have to know our enemy better. The first steps in gathering that knowledge are being taken in Boulder, Colorado. Here, a NASA-sponsored mission is in the final stages of preparation. It's called Mission Deep Impact. The objective, to rendezvous with a comet, Tempel 1, and crash into its frozen center. This is the first mission of its kind. Scientists calculate that over 1 trillion comets travel through the solar system, although their orbits only rarely bring them close to us. But they're fast. A comet could slam into the Earth at nearly 150,000 miles per hour. Mission Deep Impact uses 2 spacecraft: the larger mothership or flyby, and the impactor, which navigates into the path of Comet Tempel 1. The comet will smash into the impactor at 23,000 miles per hour, creating a crater the size of a 7-story building. The flyby will record the impact event. But is there any danger of the impact changing the orbit of the comet, sending it hurtling towards us?
The comet itself is 3¼ miles in diameter. The impactor is about 1.5 yards wide. So it's essentially the same as a mosquito being overrun by the windshield of a truck. There's really no chance that we're going to destroy the comet or even divert its path.
Soon we will know what lies at the heart of a comet. But we still have very few clues about the makeup of the other celestial rocks. The asteroids. Currently, researchers think there are 3 types of asteroids. They could be one solid piece of rock, or they may be 2 rocks joined together, or they could be a series of smaller rocks held loosely together, a so-called rubble pile. So how do we defend against them? The popular myth, fueled by Hollywood blockbuster movies, suggests that we simply blow them apart with a nuclear bomb. To demonstrate how an asteroid might react to nuclear bombardment, planetary scientist Eric Asfaug conducts an unusual demonstration. He's showing what would happen if we tried to destroy the three very different types of asteroids. The rubble pile, loosely held by gravity. The binary, side by side through space. The monolith, one solid slab of rock.
Well, let's see what happened here. The monolith, which was the largest chunk of rock, all that's left. And if you go to the next weaker asteroid, the contact binary, you've actually got a couple of pieces here that are left. You know, there's not much to say for it anymore, but there's a couple of sizable fragments. And then if you go all the way over to the weakest of them all, most of the original mass of the rubble pile is still here. And if there's a little bit of gravity over the next hours after that collision, this rubble pile might gather up its pieces again and form itself again into the original asteroid. It's not necessarily the strongest asteroid, which is the one that's going to survive impact bombardment.
But how can we know how a real asteroid will react to our attempts to annihilate it? At NASA's Ames Research Facility in California, naked science watches the destruction of a genuine piece of meteorite. It fell to Earth in Northwest Africa. We're using the awesome power of NASA's hypervelocity gas gun. Its bullets hit the target at 13,000 miles an hour. Under the guidance of scientist Dan Durda, researchers placed the meteorite in a vacuum chamber to simulate conditions in space.
If one day we need to go out and deflect an asteroid, push it out of the way, prevent it from hitting us, we'd like to know how real asteroids behave to being, pushed and prodded.
The total destruction test is designed to shatter the meteorite into tiny fragments. They're testing how different meteorite materials react to the impact.
Oh, that was great. Good shot, good shot. And I think it's pretty safe to say that was a super catastrophic fragmentation.
The experiment on this tiny version of an asteroid confirms the results of our rifle demonstration. Once again, the single piece of rock shatters into 1,000 fragments. But how would a real asteroid react? To really know, we'd need to repeat the experiment with a massive lump of space rock. But single asteroids are not the greatest threat. Rubble piles could prove more dangerous. Most asteroids in near-Earth orbit are sent there by collisions within the asteroid belt. Most scientists believe that such collisions would break apart a single asteroid. So, most asteroids approaching Earth are likely to be rubble piles. How do you ward off a threat like that? Asteroid expert Eric Asfaug.
The Earth is a tiny little dot in the ocean of space. It's the smallest target, and this asteroid, if it's destined to collide with Earth, that means it's very lucky. It's threading its path through space, orbit after orbit after orbit after orbit, and it's finally going to hit us, maybe 100 years from now, maybe 200 years from now. All we have to do is make it miss. To make it miss, if you find it early enough, all you have to do is push on it and change its orbit. And if you can do that, it'll just go sailing right past the Earth. It would be a dramatic sight rather than a calamity.
But pushing a giant asteroid away is risky business, and the consequences if we fail are almost too appalling to contemplate. We're talking potential global destruction. And yet we may be able to avoid it. Proposals do exist to move an asteroid the size of a mountain. Naked science is on the trail of a potential Armageddon asteroid. The question: if one starts heading our way, can we save ourselves from it? We've analyzed the warnings from history, asteroid impacts from the distant past, the extinction of the dinosaurs. We've met the small band of asteroid hunters on the lookout for space rocks on a collision course with Earth. So what else can we do to combat asteroids that are going to mess with us? In San Francisco, there's a man with a plan. Former astronaut Rusty Schweickart. Schweickart was lunar module pilot on the Apollo 9 mission in March 1969. This mission was the first test of the lunar module in space. Schweickart also undertook a 47-minute spacewalk.
It may be because I've flown to space and seen the Earth from outside that this is particularly important to me. There's certainly no question, looking down at the Earth, that one gets a sense of a very extremely precious place. I mean, you realize that everything you care about is down there on that planet. And it's a small place, and it is vulnerable in the long run.
The U.S. government has at least allocated an annual budget of $4 million for tracking asteroids that might hit us. But there's hardly a dime being spent on protecting ourselves if we do find one. Rusty Schweickart believes he has a way of creating an effective defense system. He intends to build a spacecraft, an asteroid tugboat, that can fly to an asteroid, dock with it, and then gently push it to change its orbit. It may sound like science fiction, but Schweickart believes it will work. He knows the only way to prove that his vision can become reality is a practical demonstration. If it works, humankind could control its own destiny.
We humans can assume responsibility from this point forward, we believe, for protecting the Earth from this evolutionary, historical shaper of life on Earth. And now that we're on top of the evolutionary heap, we don't want to go the way of the dinosaurs anymore.
Schweickart's defense system is a radical departure from previous ideas on how we deal with dangerous asteroids. He believes that trying to move the asteroid with extreme force would have little or no effect. The asteroid would either absorb the punch or would simply reform. Instead, Schweickart proposes a gentle push over a large surface area. But this mission currently exists only on the drawing board.
Heaven help us if one has our name on it and hits within the next few years. We're looking at something like 15 or 20 years to develop this kind of a capability.
There's another idea for a planetary defense system in Arizona. Jay Milosh of the University of Arizona in Tucson has a very simple solution to the problem. He wants to use the power of the sun to divert any incoming asteroid.
I'm going to use this grapefruit to demonstrate the technique of focusing sunlight and getting some material to vaporize. Now think of the grapefruit as an asteroid that might be very slowly rotating, once every 4 hours or so. And we bring our solar collector up and focus down on the asteroid, and in time we should see that the asteroid begins to be singed. And if we're lucky, we'll see a little smoke coming out. We've heated the surface up to the point that material is vaporizing. This vaporized material then acts like the exhaust of a rocket. Very slowly and very gently pushes the asteroid out of collision course with the Earth. The idea of using solar energy, free and abundant in space, focusing that on the surface of the asteroid and vaporizing it, causing it to make a little jet, sort of like a solar-powered rocket, where if we could keep the sunlight on it for long enough, the asteroid would simply move away and move out of a collision course with the Earth.
Already, a company in Los Angeles is making solar reflectors. The largest manufactured to date is 42 feet in diameter. Jay Malosh believes that his solar reflector would need to be at least half a mile across. That would take at least 3 years to build and would cost tens of millions of dollars. But why spend money on new technologies such as massive solar collectors or asteroid tugboats? Surely a big enough bomb will get rid of anything.
In terms of the nuclear option, people have been watching movies too long. They get the idea that detonating a nuclear weapon causes an asteroid to just evaporate and the parts scatter to the winds, essentially. In fact, that doesn't happen. An asteroid, half a mile or a mile in diameter, is a mountain, and you're trying to move a mountain with a nuclear weapon.
The Soviet Union detonated the biggest nuclear weapon ever, a 60 megaton bomb. You would need a bomb with the equivalent of 1,000 megatons or more to deflect a large asteroid. But no nukes need apply, because there's an even greater drawback with the nuclear option.
Even if you do manage to break it up in small fragments, those fragments are still targeted on the Earth, and they're now radioactive.
The threat of an asteroid impact is real. About a 1 in 20,000 chance of wiping out millions of us. But scientists are working on a protection plan. They have already found over half of the large near-Earth asteroids and hope to locate 90% of them within the next 4 years. Once we know where they are, we can calculate their trajectories and see if they might hit the Earth.
It's one of the very, very interesting natural hazards. It's the only natural hazard where, in principle, we can tell exactly when it's going to happen. Imagine doing that for a volcano, being able to say this volcano is going to erupt to the minute. 184 years, 12 days, 7 hours, 13 minutes, and 12 seconds from now. So we don't have any predicted impactors yet, but once we discover one that is going to be on its way, and we know exactly when it's going to happen. And it's also a unique natural hazard because we can do something about it.
No government is spending serious money on ways of deflecting these Armageddon asteroids. The question is, how many of them could pose a threat?
I can tell you right now, we know of maybe 3,000 asteroids out there and about 1,000 comets. But what about all the objects we have not yet discovered? I can tell you nothing about those. I can tell you nothing about the fact that there could be an object right now that's going to be coming into the sky while we're doing this interview, exploding loudly and scattering us all, because we haven't discovered it.
We haven't found them yet, but we know they are out there. Asteroids on a collision course with Earth. If an asteroid just a few miles across were to strike tomorrow, we could go the way of the dinosaurs. If we have enough time to work the problem, we could avoid the dinosaurs' fate. But the clock is ticking. Somewhere out there, a killer asteroid may be heading our way.